Welcome back to The Explainer. Today, we are diving into something that is literally one of the most profound, mind-bending topics out there right now, the collision of artificial intelligence and human evolution. For millions of years, the development of our species was guided entirely by the slow, kind of blind forces of natural selection, right? But today, the accelerating capabilities of AI suggest we might be right on the edge of taking the wheel ourselves. Evolution has always been a natural process. But what happens when AI takes control of it? I mean, imagine a future where artificial intelligence actually designs stronger, smarter, completely genetically optimized humans. We're talking about a world where weakness, disease, maybe even certain emotions could be edited out or just removed completely. Now, sure, while this could create a vastly more advanced civilization, it could also erase the very things that make us truly human. Society could literally fracture down the middle, dividing between enhanced people and natural humans. So the massive question guiding our explainer today is this. If AI controls evolution, will humanity survive as we know it? Section 1. Evolution's new AI co-pilot. So to really wrap our heads around how AI is already directing biology, let's look at a concrete real-world breakthrough from Stanford Medicine. Researchers there just developed something called CRISPR-GPT. Normally, using CRISPR to edit a genome is incredibly tedious. It requires a massive amount of trial and error, even for top-tier experts. But this large language model completely flattens that learning curve. A researcher literally just types their end goal into a chat box. The AI, which is trained on 11 years of published scientific data, immediately designs the experiment. It even goes a step further and predicts dangerous off-target edits to avoid damaging the DNA. It takes a process that used to take years and condenses it into months. It's a real game changer for editing the fundamental code of life. But AI isn't just editing genes. It's stepping into the realm of selecting which humans are actually born. Look at the recent research coming out of Monash University. They are analyzing how machine learning algorithms are being used right now in IVF treatments. These AI tools evaluate and select the human embryos that have the highest chances of a successful pregnancy. And while that absolutely improves fertility outcomes for families, it drags some massive philosophical questions right into the present day. We are now letting computer algorithms make calls about who is brought into the world. Naturally, that sparks serious debates about algorithmic bias, lack of transparency, and the potential dehumanization of human reproduction. Section 2. Designing the post-human future. Things like CRISPR and embryo selection, those are just the tools. But what is the actual ideology driving this intense push toward radical human enhancement? Well, to understand that, we have to talk about transhumanism. As it's outlined in the literature, transhumanism is an intellectual and cultural movement that advocates using advanced technology to fundamentally overcome our biological limitations. From the transhumanist point of view, our physical bodies are basically a trap. The ultimate goal is to liberate humanity from what they call biological slavery, using biotech, nanotech, and cognitive science to just completely evolve beyond our current physical state. The philosopher Nick Bostrom has a really striking way of reframing this push for technological transcendence. When people bring up the risks of creating artificial general intelligence, or AGI, he argues that developing superintelligence isn't like playing Russian roulette. Instead, he says it's more like undergoing a highly risky surgery for a condition that is already fatal. And what exactly is that fatal condition? Well, it's the current state of humanity itself. To put that fatal condition into perspective, just think about this number, 170,000. That is roughly the number of people who die every single day globally from aging, disease, and systemic bodily failures. Bostrom brings up this concept of temporal discounting. Basically, if AGI and advanced biotechnology have the potential to cure diseases and halt aging entirely, then delaying their development isn't the safe, responsible bet. Delaying it actually costs hundreds of thousands of lives every single day. From this perspective, human biological frailty is the disease, and superintelligence is the urgently needed cure. Section 3. Subtle shifts in humanity. Now, while transhumanists are totally actively advocating for that kind of directed evolution, there is an entirely different path we are already walking, and it's a much quieter one. Let's compare these two trajectories. On one hand, we have the deliberate genetic engineering we just talked about. But on the other hand, we have the invisible, everyday effects of technology. According to research published by Rob Brooks in the Quarterly Review of Biology, AI is already shaping our evolution whether we realize it or not. Our heavy reliance on algorithms is actually predicted to accelerate evolutionary trends, things like shrinking brain sizes, shifting attention spans, and even changes in personality types. Even our social and mating behaviors are evolving as dating algorithms start to basically dictate human reproduction. It's very much a frog in boiling water scenario. The research suggests that human AI interactions are acting almost exactly like biological ecological relationships. Think about how predators, prey, or environmental changes shape a species over thousands of years. Well, the smartphones in our pockets and the algorithms curating our daily feeds are acting as silent evolutionary pressures right now. They are gradually domesticating us and altering our inheritance patterns, and we never actually consented to it. I mean, just think about how much your own habits have changed since you bought your first smartphone. It's wild. Section 4. The Great Genetic Divide. So, whether this evolution is directed in a lab or happening subtly through our screens, it is generating immense societal friction. If you look at the literature today, you'll see two completely opposing viewpoints. On one side, you have the transhumanist hopes. We're talking the eradication of physical suffering, boundless intellectual capacity, and this new era of post-human dignity. But on the exact opposite side, you have the fears of bioconservatives, like the political scientist Francis Fukuyama. They warn about the commodification of human life, the loss of what fundamentally makes us human, and above all else, the threat of extreme, irreversible social inequality. And that socioeconomic warning is probably the one that hits closest home. Think about it. If cognitive enhancements, genetic upgrades, and radical life extension become a reality, they're going to be incredibly expensive, which means they'll likely only be available to the wealthy. We run the very real risk of moving from a world of financial inequality into a world of hard-coded biological inequality. It's a scenario straight out of the sci-fi movie Gattaca, where unenhanced natural humans simply cannot compete in the job market or in academics against a genetically engineered biological upper class. Section 5. Successors or replacements. So, how does this all play out in the grand scheme of things? To really find out, we need to look toward the ultimate test of human survival, deep space. When we talk about interstellar exploration, we very quickly realize how incredibly fragile our current biological bodies actually are. As recent astrophysical research points out, humans face severe bone density loss in microgravity, extreme vulnerability to cosmic radiation, and, well, we require a massive nonstop supply of food, water, and oxygen. Biologically speaking, we are hard tethered to Earth-specific conditions. We are just terribly suited for the harsh realities of deep space. If you map out the timeline for cosmic exploration, a pretty clear progression starts to emerge. Right now, in the present era, we're basically sending fragile biological humans into low Earth orbit at an enormous expense. In the near future, using tools like CRISPR, we might see genetically enhanced humans specifically adapted for microgravity and radiation resistance. But if you zoom out to the distant future, the most efficient way to travel the stars isn't in a biological vessel at all. It's as fully digitized AI entities or synthetic bodies that don't need oxygen or water and don't care about time dilation. Interstellar travel might naturally, inevitably, force our transition from flesh to machine. Now, that transition is absolutely terrifying to some people, but to others, it feels deeply natural. There was this fascinating discussion on an AI forum recently regarding our cosmic legacy, and one community member summarized the transhumanist acceptance of this perfectly. They wrote, "I don't see it as a hostile or bad situation, more just us passing the torch on after we build the best child we can." From that perspective, AI succeeding us shouldn't fill us with existential dread. Instead, it's more akin to the pride of a parent watching their child completely surpass them and reach out into the stars. Which leaves us with the ultimate trade-off to consider today. As AI steps in to co-pilot our biology, reshape our psychology, and potentially carry our legacy into the cosmos, we really have to weigh the survival of human consciousness against the survival of human biology. If we successfully build the perfect descendants, whether they are genetically flawless superhumans or totally artificial superintelligences, do we inevitably make ourselves obsolete? Thank you so much for joining me for this explainer. Keep questioning,